Okay. Do you mind if I stick that battery inside?
Say hi.
Impersonating the real Effiong. And no one knows what's going on.
All that program sprang out of the relationship that generated.
No, I don't think so.
Yes, turned on.
We don't want to waste battery. Battery is precious.
When that turned off, is that second pressure?
You tested that this morning?
No.
Yeah, we tested everything this morning.
That's fine.
Yep, that's good. That's
Good.
good.
Okay.
Integrator.
The batteries get stuffed in.
Yep.
It's a high quality integration job.
Put some hot glue in as well to keep them in place.
I thought you had a little.
It's a YouTube video. You see that?
That's me.
I'm an engineer. Okay. I'll wait for that. Yeah, that still works. Just and it's much the same. Zooms. Yeah.
Oh, it's being unreliable. It's dropping out. The battery connection's unreliable.
Okay, I'll fix that.
It's not going to get the GPS fixed with unreliable battery.
I'm pretty sure he's installing every software package in the world onto his computer.
Why?
Because we might need them.
Why not?
Should I install my Linux? Should I install a Linux VM?
We lost. Yeah, listen to this. We lost my laptop.
Nick,
which
talk to the
was
camera
the,
when you're speaking,
yeah,
please.
Oh,
we
Nick,
lost-
Oh my goodness, that is your thing to say.
We lost my laptop, which is the first reserve laptop, and then following this, because we were focused on finding my laptop, we lost David's backpack containing his laptop. His laptop contained all the mission critical files and the most up-to-date program and Arduino files, and now David is just frantically trying to install the software necessary on Theo's laptop. Which is basically resulted in the destruction of it, more or less.
I'm pretty sure.
It's blinking.
If it's purple, that means it's
It's
overvolted.
blinking.
Yeah. If it goes orange, that means it's on fire.
And what's the protocol for that?
If it goes UV, that means that there might be
Windows run.
Window and then go out that. You see the door at the back?
The protocol for either short-circuited lithium polymer batteries or a purple LED, orange LED coming up on the landing module is chuck out the window and
No,
bolt
the
in
landing module
direction.
spent so much time.
Good afternoon. I'm Theo Heyman, team leader.
I'm David Shaw, head of systems design.
I'm Nicholas Weniger, head of mechanical design. I'm Josh Effiong, head of outreach, and we're representing Team Nova from St Paul's School, London.
When we formed the team last June, we realised that having a well-defined team structure and excellent communications was key to a successful project. Accordingly, we formed into 3 key subgroups: systems design, mechanical design, and outreach.
Although subgroups met a number of times each week, the whole team met for a 15-minute progress update every Monday, alongside email and Skype. This allowed the whole team to keep up to date with the project. We also used Dropbox and Google Drive for collaborative work.
The first major decision was a selection of a suitable secondary mission. We chose to develop a semi-autonomous rover capable of two-way communication with base station. The main purpose was a proof of concept. There are clear benefits to micro's reconnaissance vehicles, both from a military perspective and on Earth, and of course for extraterrestrial exploration. Next, we had to build.
One of the most important things to consider was how the rover would move itself. We decided to use 2 tracks, each one actuated by 1 wheel. To create enough traction between the wheels and the tracks, we used Velcro, hook side only.
We then focused on designing the electronics necessary for two-way communications and control. For transmission of data and commands, we decided to use a long-range Wi-Fi network. This necessitated a reasonably powerful processor, and led us to choose the Gumsticks Overo, a tiny Linux computer.
We also designed 3 custom PCBs. The PMU board generates the voltage levels necessary for each subsystem. The MCU board features an Atmega 328 microcontroller that handles communication with the sensors and motors. And the CPU board breaks up the signals into 1.8 volt logic connectors for the Gumsticks.
The next challenge was fitting all that technology into a can. We used computer-aided design to model the rover. This enabled us to make repeated revisions of the design and visualize it in full before manufacturing the can. We used the HP Design Jet 3D printer to create the shell of the rover.
Because our rover had a number of mechanical parts, we needed to design a casing to protect the rover during descent and landing. We decided to use 2 subshells, which are hinged at the bottom and secured at the top with a rotational hook.
This also required an entirely new electronic system, which was to communicate its location over 433 MHz radio. This system records temperature, pressure, acceleration and GPS data, and uses this information to determine when to open the rover for landing. This allows us to release the rover at the appropriate time, although we were also able to override this by sending a command over radio.
Throughout the design process, we wanted to ensure as many people as possible found out about the project, CanSat and the wonders of engineering. We designed and constructed a website from scratch, available at teamnova.co.uk, so that we could update a wide-reaching audience on the project's progress over the course of a year.
We encourage users from the start to comment on posts and contact us via dedicated email addresses. We recently built a forum for the site to try and further encourage visitors to get involved throughout the project, while we frequently posted on social media.
These outreach efforts were accompanied by a number of presentations to different societies at school, as well as 2 articles in school magazines. What better way to inspire the new generation of CanSat builders? We have also taken part in an international science conference, which will feature submissions from Japanese and English schools. We presented a poster at the event about CanSat and our secondary mission.
Finally, we have made much of our project open source and available to the online community through GitHub and through our forums. We will also make the design files for our CanSat available online in the future, as well as any data we record. This enables others to build on our work.
Meanwhile, the run-up to the launch campaign was running smoothly until our 3D printer jammed. This delayed the project by several weeks, leaving final integration until the last minute.
We managed to short and then burn out the flex cable connecting the camera module with the main PCB board. With the cable being very specific and no spares available, we were unable to replace this cable.
A trip on Thursday to Maplins allowed us to purchase a spy pen with a built-in camera which we managed to integrate into the CanSat. Although it functioned flawlessly at first, a track on the camera soon came loose, rendering the camera prohibitively unreliable.
The other issue was with the GPS module on the rover itself. We soon found that we would be unable to rectify this problem, because the problem was not with the module itself, but with the serial port on the gun-sticks.
Everything else was completed and fully assembled yesterday evening. Temperature and pressure are logged and transmitted by 2 distinct systems, ensuring fail-safe fulfillment of the primary mission.
We have tested the rover and all other systems, and everything is fully functional. The rover tracks are moving smoothly and the vehicle fits well into the landing module for launch.
We'd like to end with a demonstration. The rover is now powered on and is connected to Wi-Fi. By selecting the appropriate button on the interface, the rover receives a command to drive forwards, just like that.
And it's died. Literally died a few seconds ago, so my laptop went into sleep mode.
Well, we'd like to leave you with our 2 motto: Si facere, super facere est.
If it's worth doing, it's worth overdoing.
Excellent, thank you very much.
Brilliant, thank you. Any questions from the judges at all?
Did you look at any alternatives rather than the gumstick?
We did look at a few options. There was one, I can't even remember the name now, but they would only sell us a €600 development kit. They wouldn't sell us the module by itself, so we had to basically rule out that option. Then of course there was the Pi, which was just a bit too big. It wasn't that much too big, but it was just, we could almost fit it, but we'd have no space left for batteries or motors or anything we needed like that.
To ask you, in terms of technical support, was there any bits that you need to go get specific help for, and who did you approach to help you with?
In terms of, well, from a mechanical standpoint, the only large technical support we needed was for the 3D printer. And we approached our workshop technician for that, but a lot of the unclogging was done by myself and my hardware team, which was rather interesting. But in terms of electronics...
No, there was nothing. There was one thing where I almost got support. I posted on the Gumsticks forums, but no one came up with a useful answer, so I found my own workaround instead for that problem.
We also were sponsored by RevCap Pro. We had they offered to give us support whenever we needed it. I asked them once for further advice on how to calibrate it, just because nothing was actually sticking to the base. The fix was very simple, and that's one.
Can I just ask one? Great presentation. Just tell me about the project in terms of how did you view modifications that were being made as the project was going on? Give me some comments about that.
So, for example, we initially started by designing our shell, as we said, on SolidWorks, which is a program we use at school. And we printed that out, and there were lots of things about it that just weren't quite right. So we noted down everything when we found it, and that enabled us to revise our models and come up with something that was much more appropriate for the situation. You've also seen us using the Dremel, probably.
Had the 3D printer not failed just before the launch campaign, we would have most likely have printed a third revision, of the entire project. However, it wasn't working. I got it printed 1 or 2 weeks before the event. So the Dremel came in use there, which allowed us to carve out certain areas of the model where the support material was just a bit too much, let's say, or that the internal structures, the internal support was just too much for the wiring, let's say, or say when we had to integrate the spy pen camera, it was just a bit too wide to fit into the model, so we had to Dremel out some slits on the side of it to allow us to slide the camera module in, and they're still in here, if you want to take a look. The slits here, and there, and there, they were Dremeled out yesterday, just downstairs, which was loud.
It's obviously quite a complicated project. So you're going to end up having to think on your feet in quite a lot of situations, just because it's quite hard to account for all of the different modules and PCBs and all the wiring that you need to fit inside the rig.
Oh, thank you very much. Excellent. Okay.
Sorry about the demonstration.